So moving on from the definitions we got in the first video, here we're going to actually try to apply this. So we have the same sphere, and we know that our measured value of its radius is 0.7 inches, and we're told that it's correct within 0.01 inches, and we're asked to estimate the propagated error in its volume. So that's a lot. That's a lot to do. So let's start with some formulas. With a formula, we know that volume is equal to 4/3 pi r cubed, right? Where this r is radius. So this r radius is this r radius. All right? So that gives us a place to start, doesn't it? And we also know that the change in r, the error, right? Change in r would be the error in measurement is from here to here, isn't it? It's greater than or equal to negative 0.01, but it's less than or equal to positive 0.01, isn't it? Okay, so moving ahead, this is what we're going to do. To approximate the propagated error in the volume, we're going to differentiate v to obtain dv dr. So, which is going to, well, let's just do this math really quick. So let's get this, right? And we're going to say that the change in v is approximately equal to dv. All right? So let's differentiate this, and this would give us 3 times 4 is 12. 12 over 3 is 4. So it gives us 4 pi r squared, doesn't it? dr, right? Because we started out with dv dr, didn't we? We started out with dv, right? This, look at this for a second. Let me be more clear. This is dv dr, isn't it? The derivative of volume with respect to radius, right? But we want dv. So dv, right, is 4 pi r squared dr. All I did was multiply both sides by this. You with me so far? So now all I'm going to do is just drop this in here. I'm going to fill in the blanks here. I'm going to fill in the blanks here, and this is going to look, right? I'm just going to fill in the blanks here, and we know that we have 4 pi, r is 0.7, isn't it? Because we have it from up here. Just got it there, 0.7 squared, dr. And remember that dr is plus or minus 0.01, isn't it? So our error, right? So our answer here is going to be plus or minus 0.06158 cubic inches, isn't it? So the volume has a propagated error of about 0.06. So the propagated error is about 0.06, and I got that right here because that's how I did my rounding. All right. I'd kind of hope to wrap it up here, but as I look, I'm like, you know what? How significant is this? Is this propagated error large or small? Is this a big deal or a small deal? And I said at the beginning of the video that sometimes this is critical stuff. And if I'm sitting here thinking, if you're an aerospace engineer, if one of you guys are going to do some kind of extreme chemistry, small errors can have catastrophic results. So now, if you don't mind, I'm going to continue, and I hope you're going to continue with me. I'm going to try to figure out, is this a big deal or a small deal? So I think the best way to do that is by using kind of relative terms. So I want to compare dv with v. So I'm going to actually use a ratio. So I'm going to take dv over v, which would equal 4 pi r squared dr, doesn't it? Over, and then we're just going to use that same volume that we had before, which was 4/3 pi r cubed. Is that all right? And if you just do some simplifying here, this is just some algebra, but if you do the algebra here, this over this, right, this would be 12 over 4, which is 3. Pi over pi goes away. dr is by itself, so dr there. Hopefully you're with me what I'm doing here. And r squared over r cubed is r at the bottom. Remember, this dr is not, this is dr, and pretend they're attached, if you whatever helps you, right? So then I'm just going to fit by here. I'm just going to fill in the blanks here. is equal to 3, we know that dr is going to be plus or minus 0.01, isn't it? We know that the radius here was 0.7. When we do that math, we're going to get plus or minus 0.0429. Holy hell. So this thing is off by 4 point. This thing could be off by plus or minus 4 point. Yeah. The percent error is about just over 4.25%. Is that a big deal or a small deal? I don't know. Are we building a is this ball bearing going into a I don't know, into something that can't have catastrophic outcomes? Or is this thing going into a race car, a rocket engine? Is it on a landing gear for a space shuttle? I mean, I don't know where it is. So given all of that crap, is this a big deal or a small deal? I don't know, but at least we have an idea of what it is, and we can talk about that you can talk about that in your think tank. So good work. If you haven't already subscribed, please subscribe, and your comments are always welcome.